All right, let's dive into a question that honestly sounds a little crazy.
You've seen the headlines, right? Every year, it seems like we're breaking heat records. But then, boom, you also see these insane stories about bone-chilling cold snaps. So how is that possible? How can the world be getting hotter and colder at the same time? Well, that's exactly what we're going to unpack here.
So to really get a grip on this, we're going to look at a perfect real-world example of this paradox playing out.
Okay, so picture this. Just this past January, the rest of the world is logging another record hot year. But at the same time, huge parts of the US and Canada got hit with this insane Arctic blast. I mean, we're talking temperatures dropping below minus 50 degrees Celsius. That's just wild. It's like someone left the planet's freezer door wide open. So what's really going on?
The answer, and kind of the main character in our story today, is something you've probably heard thrown around on the news: the polar vortex. So try to imagine this. Way up in the stratosphere, like 10 to 50 kilometers above our heads, there's this massive river of wind, and it's just screaming around the poles at up to 300 kilometers an hour. But it's not just any wind. It's basically a giant atmospheric container for all the coldest air on Earth.
The easiest way to think about it is like a giant spinning wall of wind. Its whole job is to keep that super frigid Arctic air fenced in, right up at the top of the world where it's supposed to stay. But what happens when that wall starts to get weak? When it starts to crumble?
Well, that's exactly what we're seeing. The atmospheric wall is definitely getting weaker. The big question is, why? What's punching holes in it? And here it is. This is the root of the problem. The Arctic, it's warming up 3 to 4 times faster than the rest of the planet. And that, right there, is the key that unlocks this entire paradox.
See, it all comes down to the temperature difference. A healthy, stable vortex needs a huge temperature gap between the freezing pole and the warmer air further south. That contrast is what powers it, creating those super strong, tight winds. But as the Arctic heats up, that temperature gap shrinks. The engine starts to lose power, the winds slow way down, and the whole vortex starts to get all wavy and wobbly.
And this kicks off a whole chain reaction. Step 1, the Arctic gets warmer. Step 2, those vortex winds, that wall we talked about, they lose speed. And step 3, the whole system gets really unstable. The best analogy is a spinning top, you know? When it's spinning super fast, it's perfectly stable, but as it slows down, it starts to wobble all over the place. That's exactly what's happening to the polar vortex.
And that wobble, it isn't just some abstract thing happening miles above our heads. Oh no, it has massive, very real, and very cold consequences for all of us down here on the ground. So as that wobbly top vortex loses its nice tight shape, big blobs of that intensely cold polar air can just break off and spill south. They just pour down over areas that are normally way milder, plunging them into a deep freeze.
And that is how you get those completely shocking temperatures we saw earlier, minus 50 Celsius, not up in the Arctic Circle, but in places where millions of people live in North America.
The disruption it causes is just immediate and massive. When that Arctic air hits, our modern world basically grinds to a halt. Just look at that one event in January. More than 14,000 flights were canceled. 14,000!
And the impact was just felt everywhere. You had major traffic paralysis in states like New York and, get this, even Texas. Over 820,000 Americans were left without electricity. Toronto got absolutely buried under almost 60 centimeters of snow. I mean, this isn't just a bad weather day. It's a full-blown crisis.
Okay, so the most important thing to get here is that this isn't just a fluke. It's not a one-off event. It's actually part of a really dangerous feedback loop, a chain reaction that has some serious implications. This brings up a question I hear all the time. People wonder, hey, if we're getting these crazy cold snaps, doesn't that kind of help balance out the global warming? You know, does it all just even out in the end?
And the answer to that is a hard no. Absolutely not. These cold snaps aren't a cure. They're not a counterbalance. They are a symptom of a warming planet. They're a giant warning sign that our whole climate system is getting more unstable and more unpredictable.
And this is where it becomes a really vicious cycle. Think about it. When the vortex spills all that cold air south, it's basically stealing the Arctic's cold, right? That actually leaves the North Pole region warmer than it should be. That extra warmth melts more of the bright white sea ice, and what's underneath? Dark ocean water. That dark water absorbs way more sunlight instead of reflecting it, which heats the Arctic even more. And what does that do? It leads to an even weaker, even wobblier vortex next time. It just feeds on itself.
And this, right here, is the main takeaway. It really shows you just how connected everything on our planet is. Something that sounds so far away, a few degrees of warming over the Arctic Ocean, can literally set off a chain of events that paralyzes an entire nation.
So what does this all mean for us? Well, the next time you find yourself shivering through one of these record-breaking cold snaps, remember that wobbling top. It's not a sign that global warming isn't real. In fact, it's one of its most dangerous symptoms. It's a warning that our climate isn't just getting hotter, it's getting a whole lot weirder and a whole lot less predictable.